So the next speaker, talking about model ages of light plains, smooth crater floors in the northern polar region. Move.
Okay. Thank you, Stuart.
Great.
Yeah, so this talk will be quite different from what you've heard so far. So there is no like AI involved. It's all very old styled, old fashioned, hand measuring crater counts and so on.
My type of work.
Yeah. Yeah, so this is actually it's a very small part of a much bigger project. That is why I asked for a short talk, because as you will see, it is very short. But then last minute, I changed one of the slides and I wish they had. But I'm like, oh no, okay. I will just make major points. So the point of this work was to basically cap and conclude I would say the first light plains model age map of the moon. So what I will be showing you here is just those for the North Pole. So next slide, please. So for those that don't know what the light plains are, these are widespread across the moon, and these are all of those smooth and flat plains that you mostly see inside floors, in between craters too. You would be able to spot them mostly on the far side, just because there is a giant basin there that likely formed these, but they are also there on the near side. Okay. So they're smooth and flat, very mare-like, low crater densities, not everywhere, but generally. They have sharp contacts, not everywhere, but generally they have sharp contacts. But they're also highland-like in terms of their albedos. So, which is why in the past they were thought to be, well, what are these? So there were different groups that hypothesized different origins for these, but it wasn't until the Apollo 16 brought back samples that they were then found mostly to be byproducts of impacts or large impacts, let's just say. Prior to this work, there have been regional maps of light plain model ages focused on specific parts, obviously, of the moon done by different groups. Hence why we have a whole range of model ages that somewhat overlap too. But in particular for the North Pole, we only have these two here. And this is Kula et al. 2000 and Kula et al. 2019, both of which looked at over 20 plains in the northern near side and or the northern hemisphere. And both of them, found this range of ages between 3.43 and 4 billion years. So our work kind of fills the very most polar gap that we didn't have. Okay, next slide, please. So how was this done? Well, it is very important, and as you all know, when you choose your count area, for it to be within 1 unit. And so in order to do that, we did that across the entire moon. So we used the latest global map of light plains that you see here. This is a North Polar view of it that we published in 2024. And from this, so we used these planes to then date some of these floors. Next slide. For the North Pole that you see here on the right, which are all of these little areas in white, and the names of which are above them, if you can read them. And the red, this is an infilling color. These are all the individual crater counts that we have conducted by hand for a change. But I do welcome, right? And I'm looking at you. And I welcome good tools that, can help us in doing that much faster and better if possible. Okay, so yeah, we looked at, well, we picked 10 to start with, I thought, and then I said, yeah, that's enough. And we chose those and we used the LDM 120 meter per pixel hillshade. Next slide, please. So then what we did, I can't see it, I am sorry. What we did is then we exported those measurements from Cube, and we used critter stats and open critter tools like we all know. And what we got was, if you look at the diagram in A, these are all 10. And they are grouped by age. And immediately what you can see is that most of them plot in the 3.9 billion years. And an example plot is in figure B. It's in an hour plot. Where if you can see it, sorry about that. But we have some of them which are the closest to the pole, okay, that are older, and they have this 4 billion year age, and it's 3 of them. One of them, if you can see in red, this one is the plot, the R plot that you can see on the right, called Desita U. This was the only plane that exhibited both, where first of all, it is confirming basically this background older age of 4 billion years. But it's also showing this again, 3.9 billion year age that is marking that something has occurred at 3.9 that resetted all of the other planes, but not necessarily influenced the entire pole. Okay. Next slide. So here is just a table with numbers of what I've just said. In the column on the left, you see the names of all of them. On the far right, on the column before the last, you can see the model ages with their eras that we found. And on the far column, these are previous work of count areas within the same crater floors. There aren't that many because there not much has been done up there, but we have somewhat consistency there too. Next slide. Now here, this is the slide that I have changed. Now this is also the first time I show the entire work in just one figure. So this map is the 100 meter per pixel web of where we are showing all of the areas, and there's over 100 of them, where we dated over 60 planes in the mid latitudes, and then 40 planes, 41 in the South Pole and 10 in the North Pole that you can see in the figures on the right. And although, and I color coded them by age. Okay, so there would be a lot to say about only this slide, but for the sake of time, I do want to point out a few things that have come up when while we submitted our papers that came up constantly. Okay, there are 2 possible ways that you can read this map, depending on what age you choose to assign to at least the last 3 basin impacts. Okay, as we know, there are ranges, and people go with different ages depending on their own reasonings. Okay, so in the papers, we do not take parts, and this is very important because this came up. You are taking parts. No, we're not taking parts. In the paper, we simply outline them, all the different ways that this map can be read and what it could mean, and we simply give options, which I will tell you now too. So I think the main point here, if we start, which was a very painful tooth, with the Imbrium age. Okay, so in this case, if we consider the oldest sample age for the Imbrium being 3.92 billion years, which is what most people go with, then clearly we don't have them in the mid latitudes, but they are observed on in the north only. Okay, This is true only for the planes we looked at. It may not be true across, every inch of this map, okay? This is true for the list of planes that we have. It could be that they just didn't make this list, but for the sake of the work that we did, we do not observe any 3.9 planes in the mid latitudes. Okay, now, and I say this because of the contradicting still, the contradicting point of the critter counting age for the Imbrium that has been coming up constantly between different groups of the 3.85 billion year age for it as compared to its sample age of 3.92. So which one is it? Well, I don't know, okay? But I simply point out that if the Imbrium is 3.92, there aren't any. But if the Imbrium was 3.85, then, which are all of these planes in red, then we can clearly see that the Imbrium would have affected most of the near side, if not even extending even south polar. However, it becomes more uncertain as you move south because you have another basin that is also 3.85, 3.86, and that is the Schrodinger basin. So it is likely that it has contributed to some of these, or if not even all of the south polar ones, but because they might have formed at the same time, then with just this work, we cannot separate them, okay? So we would be seeing more of mixtures there. And so this is important. It is not crazy because the sample ages, they are, oh my God, I finished my time. I knew it. The sample ages, they come in a range. It is not one age that is given. It is a range. So 3.85 is possible. It's just the youngest of the sample age. So it should not be excluded a priori. Oh, okay, next slide. So it is clear that the North Pole from this work is older than the South Pole. Point number 2 and 3, I have taken them from the paper, assuming a 3.92 billion year age. Then in that case, if we also consider an oblique impact for it, like it has been hypothesized in 2016, then we would have expected most of 3.9s in the southeast coming from the northwest, but we don't. So, and that is either because, as I said, we didn't happen to pick them, or because they have been covered by whatever happened at 3.8. Okay, and since it was coming from the northwest, only a little, went north. So it didn't have that much materials to have entirely engulfed the entire North Pole, but only those few planes that we found. And also, if that were true, then the 3.8 planes in the mid-lats must be coming from other post-Imbrium basins. That's it.